Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to continue on an exercise that we started in the previous video, finding the probability of looking at a number that is bigger than 1.2. In the previous video, we showed how exactly we will write that expression based on the knowledge that we have so far on the CDF. And in this video, we're finally going to use a table to get a number to this calculation. The table that I have picked for this video, which is going to be different from the one of the next video, is coming from a series of tables that usually is for engineers or statisticians studying economics or econometrics. However, this is a table, the Murdoch and Barnes, that is available online as well, or in any of the statistics textbooks that you might be using. So you might have seen it at some point during your lectures or in your statistics/econometrics journey. This is part of the Z table. One of the main things that I will keep reiterating for this kind of exercise is always figure out what the legend is telling you about this table so that you know exactly the information that you're going to find. Before we look at the legend, you can very easily pinpoint a few things. For instance, you will notice that on the first line and also the first column, you don't really have information on the probabilities. The combination of the numbers that are on the line and the columns is going to give you the z-score. Yes, the z-score meaning the number that you see on the horizontal axis here for your bell-shaped curve distribution. Which means that if you want a z-score, like in our case of 1.2, then we need to start, okay, we start in 1.2. Then do we have 1.21, 1.22? Well, if we had 1.21, we'd be looking at the second column in here, 1.22 at the third column. For us, it's just 1.2, so it means we simply have 0, 0 as continuing decimals, and out of this column in here and out of this line in here where I first started, the number of interest that I have to look at is this number right here. Which brings us to the second element of this table. So let's write them out. So axis of the table, information on the z-score, then inside is the probabilities. Which means that this table actually can be used in two ways. You can either use the information on the axis, if you're given a z-score, and find the probability, or you might be given the probability and you can find a z-score out of it. So it can be used in both ways. But what is this number exactly telling us? So we know it's a probability, but a probability of what? Because if you remember from the previous video, we said that normally the CDF tells us information of all of the area accumulated up until the number that we're interested in. So is this exactly the same? If you look at this number, it's supposed to tell you 11.51%. So if we go back to our graph, it's very obvious something is not right in here, because it's impossible that this area is smaller than the orange area. On the contrary, it actually seems like it's the opposite. So why is this information inverted? That's why the second, like the most important element is looking at the legend that you're given in the table. In this particular table, you are very clearly shown in this corner up here that the information of the numbers, like the probabilities that you are given in this table, it's actually the area to the right. So it's actually a computation of that 1 minus psi of u. It's not the actual information accumulated up until that point, which now makes very clear sense to us. Okay, so I don't need to do any computations actually because the entire expression that I was trying to find in my previous video, it's given to me straight away without me needing to do further computations. So we can write here the answer being directly 0.1151. Meaning there's an 11.51% chance that I see something bigger than number 1.2. Okay? This is one of those cases where you know what the theory tells you, and then you have to find that answer based on some numbers and tables, and the theory and what is being practically done doesn't exactly match. So always be aware of the legend so that you can make the best use and make sense, most of all, of the probabilities and the numbers that you are given in here. Before we move to the next video, let me show you one more example, since I said that, well, you can use it also the other way around, where you can find the z-score based on a probability. So in this particular case, I'm going to pick a random number, and let's say it's this 2236 in here. Now, what this number is actually telling you, if I translate that into a graph, just like they had done it, it means that you have the distribution, and you have some number in here, which you don't really know what number that is, but you know that the area on the right of that number, so anything bigger than that number, this area, you know, is 22.36%. So this number now, we can go up on both the axes and sideways. We're going to see that we're starting at 0.7, and then from up here at 0.76. Okay, so that means the number that I'm actually looking in here is 0.76, which means the probability that I see a number that is bigger than 0.76, that's actually 22.36%. And if you compare it to the probability of you seeing a number that it's actually bigger than 1.2, we can totally see that the area is bigger, and it makes total sense because, remember, 1.2 would have been somewhere in here, so obviously the area would have been smaller. This is also another way for you to double check that you've done your work fine. Thanks for following this video, and I'll see you in the next video with another table and how to use the table to compute your Z values and probabilities.